Right. Hello, everybody. My name is Job, and next to me is Ruud. And welcome to our presentation of the training efficiency become reality. We will explain what the idea is, what we are doing, and who we are. So I will take the start. My name is Job Meuter, and I'm an educational leader from the VISTA College. And we try to make new ways in our education. Let us start to explain what we do at VISTA College. As you all can read, VISTA College is a government-founded vocational educational college. Our students have the age of 16 and all kinds of direction. I am from the Department of Technology, and we try to train aerospace engineers at this moment. And let me tell you and show you what I do more, because the main thing of me is to have innovations, mostly the behavior of our students. We try to make different ways of coaching. That's very important these days, because knowledge is everywhere, and coaching to become owner of your own learning process is one of the standards that's very important in our organization. Next to that, we have a new way of thinking based on Lean, where we work with a lot of visuals that we make the thinking steps of our students visible and try to learn to see their own problems and solving it together. Next to that, we are experienced with VR and AR, also together with BlueTea, and that's why we're here tonight, to show you more what we do. Also, I'm developing training methods for the robotics. That's a new thing we try to learn our students, because we see a lot of jobs working together with robots, and we want to educate our students for the future of that. And in the end, we are doing researches for digital skills and digital humanism. And now I'm give you the word to my colleague Ruud. He's going to show you what we are doing on VR together. Enjoy.
Yeah, so let me switch my Mac. It's a simple turn off my computer, of course. So we got in contact with the school because they had a training challenge. Because how do you train the untrainable? And the challenge is that these students work in a very hazardous environment where safety is really a key issue. And secondly, of course, if you're working as an aerospace engineer, you work on extremely expensive equipment like an aircraft, and cost in replacing assets or in gaining new assets, of course, is one of the most important elements. And then also the access to the latest assets. So if you would have the chance to take a look at their training environment, then you'll see that these are fairly new parts of aircrafts, but they are not the latest ones because they fly. So that is a challenge for them, and they really want to catch up with technology. So as a company, but also together with the school, we strongly believe in the effectiveness of virtual simulation and serious gaming. And that is something we really wanted to take along in the project we did together. So first of all, let me talk a little bit about effectiveness, because when you do practical training, then the left side of this slide is the most important, because first of all, you want to allow a student to make mistakes in training. So no one does their first bicycle ride right away. You fall off once or maybe twice, and then after a while you pick up. So making mistakes is something that you need for the learning effect. And then secondly, of course, you need to be able to explore things. And sometimes during exploring, you break stuff, but then you get the chance to fix it again. And of course, this needs to be done all in a safe environment. And this is something that we really embed into the application that we created for VISTA College. On the right side, you see some elements that are really focused on the element of being digital, like the availability, which is always, or the consistency. All the solutions we create have a built-in instructor, which basically has captured the knowledge of the real instructors and teachers, but then puts it into this virtual environment. And this is always consistent. And of course, we add challenging elements to that. So the solution we created for them was a desktop game, first of all, because you want to roll out in a broad way. But then secondly, we add levels that can be played in VR as well. And this is important because these students are facing a real, true and big environment where you have large aircrafts, which then in a VR world is translated better into an element that gives you the real feeling. So, and then of course we added flexibility. And this is the part that actually BlueTea adds to the solution of the college. And let me explain a little bit on how this works and how we create this flexibility. Because creating a VR simulation, there are lots of people that can do that. But creating a true training simulation that actually can adapt to the student and how the student learns, that is something different. So first of all, we make a difference between the left side, which is what you see, which is basically your virtual asset, like an aircraft, and what you do with it, which is the right side. And what you do with it is basically your training scenario. So it's the flow through your game or simulation. And we make a real split between these two elements, because on the left side, you really need programmers to do that. And people that were trained to actually build software. Where on the right side, you need people that are basically subject matter experts in the area that you want to train on, which is, as it says, the training scenario. So the way normally applications used to be built in traditional development of virtual reality applications is that first of all, you need to create a 3D model. You can do that in any way. So you can create a 3D cloud of points. You can use an engineering model. You maybe can buy something. You can have someone build it for you. So that's basically no issue. Then you have to add interactivity, because this, on the left side, this solid state model basically doesn't have any interactivity at all. It's simply thin as air. So the interactivity is something that the student in the end interacts with. But what then happens is that these programmers also create the scenarios and then they deploy it to the end user. And using our methodology in development, we changed it a little bit. So we basically also start with this 3D model, but then secondly, we add the interactivity and then we deploy it. So basically, you have an application that holds a 3D model of your asset. It holds the interactivity, but the application itself doesn't know what to do. And then we give the freedom to the schools to actually create any scenario based on this 3D world in the way they want it to do. So doing this, we also get sort of a hardware independency. So as you can see here, the subject for them is a 3D engine. So it's a jet engine of an aircraft that the student need to work on. Then what we do is we create sort of a digital twin. So all the interactivity that the engine normally in real life would have is something that we add. But then secondly, what we add is this layer that we call Virtual Studio, which is the editing part basically for the students and for the teachers to create their own scenarios for training on this virtual engine. But it also automatically holds a virtual instructor or maybe even multiplayer support. And by doing that and by layering this, we can basically support any technology in the XR range that we know by now currently. So like AR or VR. But we can also support still desktop and mobile, which of course for trading is a very suitable, in most cases, suitable platform to be used. But also, and this is an important part in the flexibility, we allow future technology to quickly be adapted to these bottom two layers. And this makes it interesting because this is technology we don't even know yet, which of course is important because that's the technology that we want to adapt to. So the steps that we basically go through in the development is, first of all, we capture the challenge, the learning challenge or the knowledge challenge of, in this case, the college. Could be a business customer as well. But then secondly, we construct a scenario together with them. Then we start to develop, because on the left part, as you can remember, we still need software developers. And then we deliver. And in the end, then we hope, of course, to have a happy customer in this case. So this capturing knowledge is something that is very important, because we don't want to create only demonstration applications that can demonstrate how good VR or AR is, but we really want to solve a knowledge gap, which is normally the knowledge gap between the theory and the real practice. Because in between, you have a lot of knowledge that is not able to be trained in real life, but in theory, for students, it doesn't mean that much because they haven't seen it yet. So capturing the knowledge is extremely important. And then basically, based on that, we construct a scenario. But of course, because we are working with game-based learning technology, we first construct a scenario based on the things that you want to teach someone, but then we add the elements which are even more important for your knowledge transfer. And these are the elements that someone needs to face, but shouldn't be doing. So these are basically all the faulty elements in your scenario, which basically make your training into a fun training, because it challenges you. So then we start to develop. Then we create the code, we make stuff like that. And in the end, we deliver the 3D scenario to them. And to give you an idea on how this works, basically from the game standpoint, is that I'm going to show you a short video of the game that it's currently at the stage that it's at. You should be hearing some sound when I did it right, I hope. So this is the actual game.
Okay, get all the tools you need, so you can check and change the engine oil. How long must you minimally wait after the engine shuts down and before you can work on object?
But then there is this same game that uses virtual reality as well. So this basically concludes our short presentation about what we did for VISTA College, and we basically developed this together with the team of Job. So I'll close down the presentation, and if you have any questions, then let me know.